26 January 2001. As India woke to its 52nd Republic Day, the sleeping earth arose to sudden chaos. Shrugging a massive shoulder into the state of Gujarat, planet Earth began the awesome dance of death that we know by the name earthquake. Over the last 50 years, there have been earthquakes in every part of India. Thousands of people have died a gruesome death. Time and again, the nation has been shaken from its daily life to the realization of sudden disaster. Time and again, we have seen the awesome spectacle of a power beyond our control. Time and again, nature's fury has smashed lives, crushed hopes, destroyed entire communities.
Uttarkashi, Latur, Bhuj. Words that are engraved in our national memory like inscriptions on so many tombstones. Thousands upon thousands of people who never got a chance to find out what happened or what they should have done. Caught in the tragic moment, the men, women and children of these unfortunate towns were trapped in the fury of angry nature and the grip of their own ignorance. Could they think? Did the sudden onslaught leave them time to reflect? Did they tell themselves, if only we had been better prepared? We'll never know. We can only conjecture what their feelings must have been as they saw the earth arise to smite them down in that frozen moment of their tragic lives. Think about it. You and I are left to ask the questions that they never had a chance to voice, to find the answers they will never find. Answers that may save our lives. Why do earthquakes happen? How can we protect ourselves? What must we do to minimize the damage? And if the answers to these questions can save us from losing precious innocent lives, then do we need any more reasons for learning?
Around 1960, scientists came to the conclusion that the Earth's rigid outer crust was not a single piece, but was broken up into about 6 large continental plates and about 14 subcontinental-sized plates. At the boundaries of the 2 plates, 3 kinds of motion can take place. They can collide with each other. They can slide past each other. Or they can move away from each other. Scientists believe that these movements of the Earth's plates bend and squeeze the rocks at the edges of the plates. Sometimes this bending and squeezing puts great stress on the rocks. Rocks being somewhat elastic in nature, they can bend without breaking. If the stress becomes too great, the rock layer will suddenly rupture and rebound to an unstrained condition. Whenever any of these motions take place suddenly, they release an incredible amount of energy. This causes the sudden shaking of the earth that we all call an earthquake. Almost 90% of earthquakes are produced at plate boundaries. On this basis, we can identify 3 major seismic belts. One in the Circum-Pacific Belt, which encircles the Pacific Ocean, including the west coasts of North America and South America, Japan, and the Philippines. Another is the Alpine Himalayan belt, which slices through Europe and Asia. And the third one is the Mid-Oceanic Ridge Belt. The Indian subcontinent shows that the Himalayan belt is one of the seismically active regions where several large earthquakes have occurred. India has been divided into 5 seismic zones. Zone 5 denotes the most active region where earthquakes are likely to be of higher magnitudes. Incidentally, as this earthquake zonal map shows, Bhuj was classified in Zone 5. Many of us tend to believe that it is fundamentally unsafe to live in a high seismicity zone, which is not the case. Building codes and the advice of a structural engineer can always guide you in making safe houses, even in high seismic zones.
Earthquakes don't just throw up bricks and mortar, beams and buildings. They also throw up a lot of words we don't normally hear. Shock waves, seismic zone, Richter scale, focus, epicenter. And I'm sure many of us don't even know the difference between the magnitude and the intensity of an earthquake.
When a rock mass ruptures, the release of strain energy produces seismic waves. Just as wind energy causes waves in water to move across a lake or ocean, seismic waves move through the layers of the earth. The ground starts shaking because of the passage of the seismic waves through the earth's surface layer. Damage and destruction occur when this ground motion interacts with man-made structures. P waves are the fastest of the seismic waves. When P waves strike an object, they push and pull the object like a train engine bumping into a railroad car, which then bumps into another, and so on all the way through the whole length of the train. S waves, or the secondary waves, are second to arrive at the recording station. These waves are also called as shear waves. These waves are more damaging to construction than the previous. The point inside the earth where earthquake disturbance is triggered is called hypocenter, or the focus of an earthquake. And the point on the surface of the earth directly above the focus is called the epicenter of an earthquake. Different from the magnitude of earthquake, the intensity represents the direct effects on humans, their products, and the features of the Earth's surface at some place or locality, as determined by direct observation. It is an effort to quantify the level of destruction or degree of damage at a particular place measured on an intensity scale of 1 to 12. While the intensity of an earthquake varies from place to place, the magnitude remains the same regardless of location. The Richter magnitude is a number that is used to measure the size of an earthquake. The magnitude is a measure of the strength of the seismic waves that have been sent out from the focus. A scientist uses a seismograph to determine the strength of the earthquake. A seismograph is an instrument that measures the amount of ground motion that an earthquake produces. Each number on the Richter scale represents an earthquake that is almost 30 times as powerful as the number below it. This means that while an earthquake of magnitude 6 is 30 times more powerful than an earthquake of magnitude 5. An earthquake of magnitude 7 is 30 into 30, or about 1,000 times stronger than an earthquake of magnitude 5.
Can we predict earthquakes? Imagine how simple it would be if you could just warn people that a quake was going to hit a particular region on a given day. Everyone could gather their belongings and move to safety until it got over. Sorry, no such luck. Take the example of China. The earthquake that hit Liaoning in the province of Manchuria in 1975 was successfully predicted from the warnings given by a series of tremors that preceded it. People were evacuated and only a few people were injured. But the quake that hit Tangshan in eastern China the next year came entirely without warning. This time, more than 240,000 people were killed. So you can't predict which quake will be predictable.
Contrary to layman's perceptions, earthquake prediction is not the be-all and end-all of earthquake research. Studying the seismic activities is a major area of research, which also helps in identifying active faults and the likely sources of seismic activities in the future. India Habitat Centre at Lodi Road is one of the important buildings in Delhi where strong motion seismic network is operational. It consists of 16 numbers of digital triaxial strong motion accelerographs installed and maintained in different localities of the city by the Central Building Research Institute, Roorkee. This network has been able to generate real-time ground motion database for the region. The data collected from major earthquakes and local microtremors is going to play a vital role in designing earthquake-resistant buildings and preparing seismic microzonation maps of the region. These maps can help identify vulnerable localities of the city in the event of an earthquake. Tehri Garhwal, a picturesque mountain location in a highly active earthquake zone, has a recording station for collecting seismic data from the adjoining areas, including Chamoli and Uttarkashi. Dr. Ashwani Kumar, a seismologist at IIT Roorkee, is heading a project which involves recording and analyzing seismic data in the Tehri region. He carries out his work through a telemetry network in which different field stations continuously transmit the seismic data to this main station, which he and his team then study and analyze. This is one such field station at a greater height, which does the job of collecting ground motion data through a seismometer.
This is one of the remote seismological stations of the local seismological network which we have deployed around Tehri region to monitor the local seismicity in the environment of Tehri Dam site. At each remote seismological station, we have a seismometer, which is a short period seismometer, and it senses the ground motion. The output of the seismometer is fed to the digital modulator, and from digital modulator the output goes to the radio transmitters, and then from transmitter the data is continuously transmitted to the central recording station, which is located at New Tehri town.
Dr. Ashwani and his team say that this project is centered around the upcoming Tehri Dam, and the data is going to help them assess any kind of induced seismicity caused by the filling of the reservoir after the completion of the dam. Like other seismologists, while Dr. Ashwini agrees about the significance of these seismic studies and their long-term implications, he feels predicting an earthquake is something which still remains a distant dream.
There are more than 20 precursors which have been observed, but their behavior is unpredictable in the sense that some precursors they appear and some precursors their pattern is not very regular. The failure to identify a unique pattern before the earthquake is one of the reasons that we are not able to predict the earthquake.
You can't be predictive, but you can be proactive. Earthquake protection is about a whole series of measures, small and big, that you can and must work on today to ensure that tomorrow is safe. We're talking about you, Mr. Mehta, and you, Mrs. Khan, our good friend Vishwanathan out there in Chennai, Sardar Pratap Singh ji from Hoshiarpur, oh, and the Das Guptas, and Mr. and Mrs. Rodriguez. I guess you know what I mean. We're talking about all of you. The truth is, earthquakes don't kill, buildings do. Poor design, poor construction, poor maintenance, these are the killers.
The focus is on buildings. Here are some important measures that each one of you should build into your lives. 3 points to remember. If you're building a house, you can build for safety. If you are living in a house or flat, you can improve its safety. If you are looking for a place to stay, you can look for safety.
So how do we do this? Well, let's take Mr. Mehta's example first. Mr. Mehta is working with his architect and structural engineer on the plans for a dream house, what's known as an RCC or reinforced cement concrete construction. It'll have a swimming pool, bay windows, marble flooring, central AC, terrace garden. Wow, wonderful, Mr. Mehta. But Mr. Mehta, sorry to interrupt, but have you thought about earthquake protection? It wouldn't be nice if your terrace garden ended up inside your swimming pool, would it? Maybe you'd like to see if you're following a few simple guidelines.
An RCC or reinforced cement concrete structure is made of beams and columns that are actually made of cement concrete with embedded steel. The frame of an RCC house looks like this. The vertical part is called a column, while the horizontal ones are called beams. In case of such structures, the following points must be kept in mind from the point of view of earthquake safety. Columns should be stronger than beams, and also the beam width should not be more than the column's width. Proper detailing of reinforcement, which means proper amount of steel so that the desired ductility is achieved. Proper care must be taken in case of lateral ties. The ties should not be anchored at 90 degrees. Such ties open up easily during an earthquake. Instead, ties should be crossed with each other so that they don't easily open up during an earthquake shock. Adjacent and dissimilar RCC buildings should have a minimum separation of 20 millimeters per story. The asymmetric buildings undergo torsion, and the extreme corners of asymmetric buildings are subjected to very large earthquake forces. Therefore, asymmetric buildings should be avoided.
Earthquake-resistant houses don't necessarily have to be made with RCC. They can be constructed with all types of materials, including traditional materials. Take the example of masonry constructions with load-bearing walls. A large majority of rural people build and live in these types of houses. They don't consult any architects or engineers while building. They just put up walls of stone and mortar and then top them with a roof. But what's interesting is that you can still make it earthquake resistant by just following certain precautions. अब हमारे चौधरी जी को लीजिए. One fine morning he decides to build a house. He calls a mason, buys some cheap local building materials, and there he is constructing this dream house. अब इनको कैसे समझाएं?
भाई जुम्मन मिस्त्री, मुझे ना लगता तू एक हफ्ते में मकान दे देगा मैंने।
अजी आप तो चौधरी साहब बेफिक्र रहो, अगले एक हफ्ते से पहले दे दूंगा मैं।
बेफिक्र रहो?
बिल्कुल बेफिक्र रहो।
अच्छा, अगले हफ्ते मेरा गृह प्रवेश है।
अच्छा।
और तेने ये मकान तैयार करके देना है, और ना इस पर कभी छत डली है, ना इसमें सीमेंट चढ़ी है। तू कैसे बोलेगी अगले हफ्ते दे देगा भाई?
अजी मैं तो ना जबान दे रहा हूँ, अगले हफ्ते बिल्कुल पक्का दे दूँ।
तो जुम्मन मिस्त्री, ये बात तेरी जिम्मेदारी रही कि अगले हफ्ते जो मकान तैयार करके मुझे दे रहा है।
बिल्कुल पक्का दे रहा हूँ।
देख ले भाई, अब बनता तो गया कुछ, तो बन गया है।
चौधरी जी, घर बना रहे हो क्या?
हाँ जी, बन तो घर ही रहा है। अब ये जुम्मन मियाँ बना दें तो खैर मनाए। भाई जुम्मन मियाँ, अगले हफ्ते ये मकान मुझे तैयार चाहिए, जैसे भी।
चौधरी, जैसे भी? तुम्हें मजबूती का कोई ख्याल नहीं?
मजबूती? भाई रोड़ी है, सीमेंट है, ईंट है, सरिये लगे हैं, और क्या मजबूती चाहिए?
अरे भैया, इतना मजबूत तो होगा कि तुम्हारे धक्के को सह ले, पर भूचाल आया तब क्या करोगे?
भूचाल?
हाँ, भूचाल। भूचाल कभी बोल कर नहीं आता।
भाई भूचाल के लिए कोई स्पेशल मजबूती चाहिए क्या?
बिल्कुल स्पेशल मजबूती चाहिए। कहो तो समझाऊं?
समझा भाई, समझा। बैठ जा जुम्मन भाई, तो क्या मजबूती है भाई स्पेशल, समझा।
Unlike RCC structures, where strong columns are there to take the load of the building, in load-bearing or wall-bearing types of construction, the load is borne by the walls. Such constructions are most prevalent in rural and semi-urban localities. These constructions, often called masonry construction, can be made earthquake-resistant by following certain guidelines. Earthquake bands must be provided to make a masonry construction earthquake resistant. These bands are nothing but a reinforced concrete member running over all the load-bearing walls of a building. Earthquake bands can be at roof, lintel and plinth level. These bands integrate all the walls and avoid separation. Vertical reinforcement at the corners and junction of walls is also provided. This can be well understood with a shock table demonstration by earthquake engineering experts.
Well, under the huge shock, how this building has performed, which has earthquake bands, earthquake resistant elements, it has damaged but not collapsed. The same type of building, if these provisions were not there, then the building would have collapsed. Exactly this has happened during Uttarkashi earthquake, Latur earthquake, Kilari earthquake and the Bhuj earthquake. All buildings which did not have this type of provisions collapsed, along with them the inmates and the property had perished. So it is advisable to provide these bands. This has come into the Indian Standard Code of Practice. This provision has come and it can be used.
For brick or stone masonry, timber bands with mud mortar can also be provided, which can provide high strength at low cost. In the case of pitched roofs, gable ends are subjected to high earthquake forces. Gable bands can be used to protect gable ends. Alternatively, hipped roof should be provided. Long walls of more than 5,000 millimeters should be avoided. For such lengths, a reinforcement must be provided in the middle, or it should be joined by a cross wall in the middle. To avoid splitting in rubble masonry walls at joints, through stones should be provided in sufficient number. Openings like windows, doors and ventilators weaken the walls. Therefore, the size of the openings must be small as far as possible, and they should be provided away from the corners and from each other. To compensate the loss of strength due to openings, reinforcement should be provided around the openings. If a pitched roof is required, the two slanted roofs should be joined through what are called bracing members. Projecting parts and attachments, such as balconies, parapets, suspended ceilings and the like, should be avoided as far as possible, as these are the parts to get damaged and fall first. If provided, these should be secured to the main structure of the building using proper reinforcement. The height of the parapet should be small, and it should be properly secured to the building.
Just after the Bhuj earthquake, a very interesting incident took place. A friend of mine who was looking out for a house to buy went to the construction site of a new apartment block to meet the builder. Impressed by the look and design of the building, he simply asked the builder, "I'm sure you must have followed the earthquake code of the Bureau of Indian Standards?" The builder replied, "Sir ji, safety is no problem, but ye code word ka kya chakkar hai?"
This is the Bureau of Indian Standards located at Manak Bhavan in Delhi. What many of us don't realize is that the BIS has provided specific guidelines in the form of building codes for earthquake-resistant buildings. For low-strength masonry construction, BIS guidelines 13823 1993 can be followed. For earthen buildings, guidelines 13827 1993 can be followed. For multi-storied construction, BIS code number 4561893 and 4326 13920 should be followed. But unfortunately, many builders are neither aware of these codes and guidelines nor obliged by law to follow them.
So what do we do? If builders are unaware and they are not bound by law to follow the Bureau of Indian Standards earthquake safety codes, the answer is that we can educate ourselves about very basic but very crucial points related to our safety. One major concern for safety is related to multi-storied buildings, an unavoidable part of any big city or metro. How many of us think of earthquake safety measures when we buy or rent a flat in a multi-storied apartment? Let's ask Mr. and Mrs. Khan, who have just seen a multi-storied apartment in the outskirts of Delhi and are going gaga over it.
भाई आज इतने फ्लैट देखे कुछ समझ में नहीं आ रहा था कौन सा फ्लैट पसंद आएगा। थैंक गॉड एक फ्लैट तो पसंद आया। भाई ये प्रॉब्लम तो सॉल्व हो गई, अब मुझे और कुछ नहीं चाहिए।
कहाँ से आ रहे हैं मिस्टर एंड मिसेस खान?
भाई एक फ्लैट खरीदना था, वही देखने के लिए गए थे।
कहाँ? मल्टी स्टोरीड में?
हाँ हाँ, मल्टी स्टोरी हमें बहुत पसंद है।
तो कोई पसंद आया?
अरे क्यों नहीं भाई, वो वाली बिल्डिंग हमें बहुत अच्छी लगी जिसमें ग्राउंड फ्लोर पर पार्किंग स्पेस इतना अच्छा बनाया हुआ है कि पूछे मत।
चलिए बढ़िया है, पर एक बात है, अगर ऐसे मकानों को बनाने में सावधानी नहीं बरती गई हो तो ये अर्थक्वेक सेफ्टी के लिहाज से कमजोर साबित होते हैं।
पर क्यों? वो कैसे?
Multi-storied buildings are basically RCC structures, which should follow almost all precautions desirable for any RCC structure. However, there are some specific points which must be taken care of in the case of high-rise buildings. There should be enough strong columns to take the load of the building. These columns should be tied together so that the buildings will rock together as a whole and will not slide under the roof, which would be dangerous. Buildings with parking lots and such like on the ground floor are known as soft first-story buildings. Buildings with a soft first story should be avoided. Soft stories attract large earthquake forces and require very large ductility. To make the stiffness of the ground story comparable with that of the upper stories, large columns and beams and shear walls have to be used. The foundation plays a prominent role in the case of multi-storied buildings. Such buildings should preferably not be constructed on reclaimed land, such as filled up marshy land or river plains. In sandy soil areas, the foundations have to go down deep in the form of raft or pile foundations. Let's understand this phenomenon through three models of houses similar in construction but with different types of foundations.
You have just seen the three buildings behave differently, having different foundation system, strip footing and ref foundation and with pile foundations. The building with the strip footing has sunk and tilted, and this has performed better. This whole thing is raft is closed. It did sink a little bit but not much, whereas this pile foundation has performed very well. It didn't allow it to sink or tilt, and this is the best foundation under such conditions.
Because such soils have a large water content, in the event of an earthquake, soil gets shaken up and densifies, causing the water to rise. This is known as liquefaction of soil. This causes buildings with weak foundations to either tilt or sink. Site selection. A geotechnical survey or soil exploration must be carried out to select the site so as to avoid places of very weak soil.
Talking of earthquakes reminds me of another incident. It was in the month of February last year. The Bhuj tragedy was fresh in our minds. One day my Bengali neighbor Mr. Dasgupta came rushing to me and said, "Naseer bhai, Latur mein ho chuka, अब भुज में भी हुआ, अगर अपने मुंबई में हुआ तो अपन कहां जाएंगे? अपन को तो ये भी नहीं पता कि अपना बिल्डिंग अर्थक्वेक का झटका ले पाएगा कि नहीं." First I tried to laugh away his fear, but later I thought seriously and consulted a structural engineer who told us that the building is safe and can withstand the earthquake shocks. But that left me wondering once again, what if his answer had been no? I expressed my doubt to him, and he told me that there is nothing to fear even if your house is not properly earthquake resistant. You can still make it so by adopting simple, cost-effective and convenient techniques. So don't panic, just take the right measures.
There are ways by which an existing house can be made earthquake resistant. Any qualified structural engineer can advise you on this. For masonry structures, retrofitting can be done in the following manner. Improve the strength of walls by cement or epoxy grouting. In the case of stone walls, stitch the walls with through stones or steel bars. Attach wire mesh to the face of the wall and cover with plaster. To understand this better, let's go to Radhanpur in Gujarat. Here, people from nearby villages and towns are gathered to see how stone or rubble masonry construction can be retrofitted.
लेकिन वो ये देखने में आ रहा है कि this particular specimen here is as traditionally built. So the traditional masons and carpenters were employed to construct this. Exactly similar was constructed the other one. After doing the construction similar like this, that was retrofitted by applying certain elements. This is the condition, this particular specimen on the point of total collapse, whereas the strengthened one is still standing. This is a very interesting phenomenon which always happens in stone masonry, that there are two layers of stones, one inside, one outside. At the time of shaking, the two tend to separate out and one of the layers tend to fall out. Now this is the weakness that must be safeguarded against. What do we do that? As you see here, these header elements, they were incorporated after the model was constructed. How they were constructed? A hole was made through and a steel rod was placed inside and concreted. So this becomes an element which connects the outer layer of the stones and the inner layer of the stones. Now in this case, that particular happening will not take place. Another element that was incorporated here is this, which we call seismic belt or Bhukampiya Patti. Now this is installed afterwards by using a weld mesh or iron jali, which is fixed to the wall by means of nails or other fixing elements, and then this mortar is applied. Mortar has to be strong, at least 1:3 cement and mortar. Once we do that, then all these walls are integrated. Now there is another element that we have provided in this house that is to be seen from inside, not from the outside. That is a vertical reinforcing bar which goes at the corner of the two walls like this, and it gets connected to the foundation, connected to the roof. Now there are 4 such bars, one at each corner. So now 4 vertical bars, this seismic belt, these header stones, now they make this house earthquake safe. In addition, where we have these triangular walls at the top, those also have to be enclosed in this same Bhukampiya Patti system. So this triangular wall also does not fall out. Now another detail that you see here is that when we do this, the wooden rafters are now held down to this Bhukampiya Patti. So even they cannot be displaced by the earthquake. Also during cyclone, this roof cannot fly off. So in one go, we have taken care of the cyclone safety as well as the earthquake safety.
For the retrofitting of RCC-type buildings, the following guidelines should be applied. Visual inspection by an expert to identify the visible weaknesses of the building and requirements of in-situ testing and detailed dynamic analysis. A detailed dynamic analysis based on the actual in-situ strength of concrete may be performed to locate weaker members. The weaker members may be strengthened as mentioned earlier. To increase the strength of beams and columns, extra steel should be placed and jacketed with extra concrete. Steel jackets may be provided to columns and beams to improve the ductility. In the case of buildings with stilts, increase the column and beam sizes to avoid a soft story effect. Some RCC walls may be added at the ground story in such a way that these do not hinder the usage as parking. Steel bracings between the columns will also be helpful.
So far, we've told you a little about earthquakes and how they happen, as well as the different measures for earthquake protection in building construction, location, and design. But earthquakes will still happen. So you also need to know a little more about the forces released by an earthquake, the way they affect buildings, settlements, and human beings, and to learn some survival skills. Two of the most dangerous forces released by an earthquake are ignorance and panic. Together, they probably injure and kill more people than the earthquake itself. In the event of an earthquake, here's what you should be doing. And remember, what you don't do can be as important as what you do.
When an earthquake occurs, one must do the following. Hide yourself under a bed or table. If this is not possible, stand in a corner or under the doorway. If you are in a single-story building, go out immediately into the open. But if the building is multi-storied, then don't rush to the staircase. Also, if caught outdoors, the rules to be followed are: rush to an open space. Now, let's see what we should not do at the time of earthquake, or even after the shocks are over. Do not use matches, lighters, camp stoves, and electrical appliances, and avoid any gas leaks. Do not light your kitchen stove. Do not use your phone except for a medical or fire emergency. You could shut off power at the control box if there is any danger to house wiring. Do not eat or drink anything from open containers near shattered glass. Do not create panic by spreading false rumors. Do not ignore other people in distress if you are not hurt. Assemble outside after the earthquake ends and do a head count to check on the status of the neighborhood. There are ways by which one can prepare oneself for a calamity like an earthquake. A torch, a helmet or a sturdy hat, shoes, a battery-operated radio, fresh batteries, drinking water to last 3 days, and food to last 12 days. These are things that should always be present in a house for basic earthquake protection. It takes time for a region shaken by the sudden onslaught of nature to come back to normal. However, technology today has made rebuilding and rehabilitation easier and more effective. This school in the Kutch area has been reconstructed entirely with the help of low-cost advanced composite products like jute coir composite boards and rice husk particle boards. It's an effort by the Advanced Composite Mission of TIFAC, the Technology Information Forecasting and Assessment Council. In collaboration with Mohana Orthotics and Prosthetic Center, Chennai, and with technical inputs from the Madras Institute of Technology and IIT Chennai, TIFAC's Advanced Composite Mission has also given a new lease on life to many of the people who lost their limbs in earthquake disaster. These below-knee endoskeleton limbs are adjustable, aligning themselves with the body's load-bearing structure as it shifts. They're functional rather than just cosmetic replacement for severed legs, allowing a near-normal gait for those who use them. The composite limbs are lightweight, better in control, and more natural in appearance.
Telecommunications are the first casualty in an earthquake-affected area. On such occasions when nothing works, particularly in remote areas, a small gadget has often come to the rescue. Known as ham radios, these devices have played a major role in the recent Gujarat earthquake by communicating important messages. A small gadget, but a major device which can come in quite handy when disaster strikes.
So you're coming very nice, Karan, and 5 and 9 clear copy with your rubber ducky. So
Ham radio has had a very important role to play in natural disasters, like the floods in Orissa or during the recent Gujarat earthquake. Amateur radio operators are often called ham radio operators. Ham operators can fill the communication gap within the shortest possible time. These operators use high-frequency, long-distance radio sets, as well as very high-frequency, short-range radio sets to convey messages.
Well, I hope you benefited from this program on earthquake safety. You see, there is a lot of research going on in this field, and many wonderful life-saving devices are being designed to help you survive the sudden violence of our dynamic planet. But the most important instrument that can make the difference between life and death will always remain this little gadget that's fitted on your neck. It's called the brain, and all it needs to work is the right knowledge. Knowledge that can prevent you from quaking with fear, knowledge that can help keep your feet firmly on the ground. Goodbye, take care.
Ah